Hey, Flipped Geometry, how you doing? We are coming into the final stretch of Chapter 2 here, Lesson 2.8 on bisectors and proofs about them. So, still building proofs and still learning how to think logically. This time we're using bisected angles and bisected line segments for the purpose of this exercise. So, without any further ado, let's jump right in. So graphically, the main idea of this particular section is to find the middle of something. We've already identified a midpoint. Midpoints, remember, are sections where the distance from one end of a segment to the point is the same as the distance from that point to the other end of the segment. So graphically, if you had a line segment and a point in the middle, you could make little hash marks and show that this segment is the same measure as this segment, and so M is the midpoint of the unit. So let's use this concept in an example here. I have a segment RT, and M is the midpoint. And I know where R is, one of the endpoints, and I know where M is, the midpoint. I don't know where T, the other endpoint, is. So I have to find T given the midpoint and the other endpoint. I know because M is the midpoint that MR and MT are congruent. They're the same length, the same distance. And so if MR is 5 minus 2, absolute values, because I don't care about the sign at this point, I just want the magnitude of the difference. The distance there is 3. So I know that if MR is 3, then TM or MT must also be 3. And so I've got 3 on one side of the midpoint. I need to have 3 on the other side of the midpoint, right? Well, here, R is at 5, so it's 3 more positive than the midpoint 2. So I'm going to go more negative than the midpoint. So 2 minus 3 is negative 1. And so I've got one endpoint at 5, the midpoint at 2, and the other endpoint at negative 1. So T is at negative 1. It would look like this. RT, the distance here is 3. The distance here is 3. Okay? If you need some more help with that example, go ahead and rewind the video and look at that again. Another way of saying that same idea would be this theorem, that if M is the midpoint of AB, then AM is 1/2 of AB, right? I've got a distance from A to B, and M is the midpoint, so AM is half of the distance of the whole segment. It's a pretty common sense idea, right? You've got something, you've got the middle of it, you found half the distance. So if you have 2 endpoints and you want to find the midpoint, using that idea, you would just average the values of the 2 endpoints, right? So the midpoint is the average of A and B, A plus B divided by 2. In that example we just had with negative 1 and 5, negative 1 plus 5 is 4 divided by 2. The midpoint was at 2. Okay, so that's just a quick way of finding the midpoint of a segment. The next idea we're going to talk about is a segment bisector. Now we found a midpoint of a segment, and that is a point that divides a segment into 2 equal portions, right? But now we're looking at not a point, but another line segment that intersects a line segment and cuts it into 2 equal portions. So a segment bisector intersects a segment only at its midpoint. And it's usually drawn as an arc, or it's frequently drawn as an arc, but it can also be a line segment as well. Okay? Any line, ray, or segment or plane forming right angles where it intersects a segment at its midpoint is called a perpendicular bisector of a segment. So you can cut a segment into halves at any angle and even with an arc. But if you happen to have something that intersects that segment at a right angle, then you have something very particular called a perpendicular bisector, because it bisects the line and cuts it into not only 2 halves, but 2 halves and 4 right angles. Okay, so we're going to create a perpendicular bisector. Now this is a construction, and in my particular teaching through geometry, I don't weight constructions very heavily. So in my class as my student, you will not get a whole lot of assignments with these, but I'm making these videos to be useful to other people as well. So we will show you how to do this just in case that becomes important to you. Okay, so construction. To construct a perpendicular bisector, I have a segment AB, and I want to construct a perpendicular bisector of AB. So I have this thing, and I want to make something that goes 90 degrees through it and cuts it right in half. Now, if I had a ruler and a protractor, this would be a piece of cake. But the rules of construction are that I only have a compass and a straight edge. So here's how you get this done. I start with my compass and I make some hash marks with my compass above and below the line with the end point of the compass here. Then I take the same exact distance and I put the end of my compass over here and I make 2 more hash marks. Now I have found the intersection of 2 arcs above and below the line, which will line up right across the middle of this segment. Okay, and now I just need to use my straight edge and draw a line that goes through those 2 points, and then I will have created a perpendicular bisector to segment AB. All right, that's how you do that. Congruent segment bisector theorem. If 2 congruent segments are bisected, then the 4 resulting segments are congruent. This is pretty simple, right? I have a segment and I can bisect it and get 2 equal halves. If I have this segment and another segment that are congruent, they're the same thing, the same measure, and I bisect this one and I bisect this one, I now have 4 halves that are all the same, right? Makes sense, common sense stuff. We've had segment bisectors, now let's talk about angle bisectors. An angle bisector is a ray that divides an angle into 2 equal angles. Okay, the ray YT is the angle bisector of XYZ if YT, except for its origin, is in the interior of XYZ and the measure of XYT equals the measure of angle TYZ. Or you could say that the 2 resulting angles are congruent to each other. So I have an angle and I draw a ray so that this angle and this angle are congruent to each other. Okay? There you go. That's an angle bisector. Angle bisector theorem, if YT bisects XYZ, then the measure of XYT is 1/2 the measure of XYZ. So you have an angle and you bisect it. This angle is now 1/2 of this angle. Okay? And I hope my little fingers help you because for some reason the publisher didn't put a lot of pictures on these slides. We'll talk about them in class. One more time, we're going to do a construction here. This is how to construct an angle bisector. And again, my students will do very little of this, but I don't know where else these videos will be used. So given angle A, we're going to construct an angle bisector of angle A, right? So here's how you do this. You start with an angle, and you're going to take your compass, you're going to put the needle of the compass here, and you're going to make a hash mark across both of the rays of this angle at the same distance, okay? It doesn't matter how big that hash mark is, but we're gonna create now 2 points of intersection, point B and point C, where that arc cuts across those rays, okay? Now, I'm going to set my compass to some other distance, smaller than it was before, and I'm going to make a hash mark that goes approximately through the middle of the angle. Then I'm going to take my compass that same exact distance, and I'm going to put the needle here, I'm going to make another hash mark. And now I have an intersection of these 2 hash marks. This radius is the same as this radius, okay? And so I have found somewhere in the middle of that angle. Now I just need to take my straight edge and go from the origin of the angle to the place where my hash marks intersected, and I have point D. And now ray AD will divide angle BAC in half. We've created an angle bisector. All right? You can see that again if you need more help. The congruent angle bisector theorem, very similar to the segment bisector theorem, says that if 2 congruent angles are bisected, then the 4 resulting angles are congruent. So just like I take an angle and I cut it in half and this is the same as this, I can now say here I have this angle and I have this angle and they are congruent. And so when I cut one in half and I cut the other in half, I now have 4 small angles that are all of equal size. Okay? Pretty common sense stuff. Oh, who turned out the lights? Oh, just kidding. We're at the end of the show. So if you have any questions, we can talk about them tomorrow in class, or you can post them in the comments field below, and I'll do my best to answer them quickly. And until then, Jesus loves you, and so do I. We'll see you tomorrow.